For the past 2 years, the James Webb Space Telescope has been nothing short of revolutionary. As the most advanced space telescope ever built, it has given us unparalleled views into the universe's deepest and oldest secrets. But beyond just stunning images, Webb is uncovering mysteries that challenge everything we thought we knew about the cosmos. It's answering questions about the very fabric of space and time, but also raising entirely new ones that scientists are scrambling to solve. From galaxies that shouldn't exist to discrepancies in the rate at which the universe is expanding, Webb's discoveries are creating more questions than answers. And yet, that's what makes the mission so exciting, because each new revelation is a step toward unlocking the universe's greatest mysteries. With its unmatched capabilities, the James Webb Space Telescope isn't just taking us on a journey through space, it's showing us the universe in a way we never imagined possible. In this journey, Webb doesn't just offer images that are beautiful in their complexity and color, it provides a window into the very building blocks of the universe. One of the most stunning revelations to come from Webb's observations is its investigation into the pillars of creation, one of the most famous regions in the cosmos. This region, about 7,000 light-years away in the Eagle Nebula, is home to vast, towering structures of gas and dust where stars are born. These pillars are so vast that their finger-like outgrowths are larger than our entire solar system. Previously, we only saw them in visible light through Hubble's famous snapshot. But now, Webb has captured the same region in infrared, offering a totally new perspective. This is where things get mind-bending. Webb's infrared capabilities allow us to see not just the structures, but also the cooler, denser parts of the gas clouds, the nurseries where new stars are forming. In fact, it's through these combined observations from Webb and Hubble that we're able to get an unprecedented 3D view of this iconic region. The visible light from Hubble shows us the hot, glowing gas, but Webb's infrared images reveal the cooler, hidden parts of the nebula, allowing us to better understand how stars form in these mysterious clouds. But Webb isn't just helping us look deeper into distant star-forming regions. It's also helping us understand the birthplaces of stars in a more detailed, tangible way. For example, when scientists look at the pillars of creation, they notice something fascinating. While the dense clouds of gas are full of baby stars still forming, these stars aren't growing in isolation. Instead, they're part of larger, more complex structures known as star clusters. These massive clusters form through intense gravitational collapse, where gas and dust come together under their own gravity to trigger star formation. Webb's infrared observations provide an incredible level of detail on this process, allowing astronomers to peer into these regions and understand the dynamics at play in a way that was previously impossible. You said. Provide at least 3 keywords: detailed, informative, and engaging text while maintaining the original tone and structure and without heading. ChatGPT said. ChatGPT. The James Webb Space Telescope, launched in December 2021, has quickly become a game-changer in the field of astronomy. For over 2 years now, it has been sending back mind-blowing images and data from the farthest reaches of space, unraveling secrets that have long eluded scientists. This telescope, a joint project by NASA, ESA, and CSA, is equipped with the most advanced technology ever placed into orbit. With its infrared capabilities, it can peer through dust clouds and see objects too faint or distant for previous telescopes, like Hubble, to observe. As it continues its mission, Webb is pushing the boundaries of what we know about the universe, uncovering new wonders that are forcing scientists to rethink our understanding of space, time, and the very origins of the cosmos. What makes Webb so special is not just the breathtaking images it sends back, but the profound discoveries it makes. From uncovering the oldest galaxies ever seen to revealing mysterious objects that shouldn't exist, Webb is challenging our long-held assumptions and reshaping our understanding of the universe. In many ways, it's like having a new set of eyes that can look deeper and farther into space than ever before. With each new finding, Webb is pulling back the curtain on some of the most fundamental questions about the cosmos, sparking curiosity and excitement among scientists and stargazers alike. And as Webb continues its mission, it's certain that even more revelations will emerge, answers to questions we haven't even thought to ask yet, and puzzles that will take years to fully decipher. One of the most spectacular revelations from Webb's mission so far has been its stunning view of the Pillars of Creation, located in the Eagle Nebula, roughly 7,000 light-years away. This region is home to some of the most iconic structures in the universe, massive columns of gas and dust where new stars are born. These pillars, towering over the surrounding space like giant fingers stretching toward the stars, have been a favorite subject of astronomers for years. When the Hubble Space Telescope first captured images of this region in the 1990s, it became one of the most famous photographs in space exploration. However, Webb's infrared observations have added an entirely new dimension to our understanding of this iconic structure. The pillars themselves are already immense, with some of their finger-like protrusions being larger than our entire solar system, but Webb's infrared observations show us even more. The infrared view offered by Webb is not just a different perspective, it's a completely new way of seeing. While Hubble's optical images showed us the glowing gas in these pillars, Webb's infrared capabilities allow us to peer through the dust and gas to see what's hidden within. We can now observe the cooler, denser parts of the gas clouds where new stars are being born. In these regions, known as star nurseries, the process of star formation is occurring at an incredible scale, but it's largely invisible in visible light. Webb, however, reveals this activity in unprecedented detail. The combination of Hubble's optical images and Webb's infrared data creates a fuller, richer picture of this region, allowing scientists to study the entire process of star formation, from the birth of protostars to their eventual ignition as fully fledged stars. This discovery is just one example of how Webb is changing our understanding of the universe. It's not just observing the stars in their adult form, but also studying the very process of their creation. When scientists look at these pillars, they're not just seeing massive structures of gas and dust, they're witnessing the birth of stars and the evolution of galaxies. Webb's ability to peer into the heart of star-forming regions is giving astronomers a window into how stars like our Sun came to be. But what makes this even more exciting is the fact that many of these stars are in the early stages of their formation. Some are still in the process of gathering mass and heating up, while others have just begun nuclear fusion in their cores. Webb allows scientists to study these baby stars and their environments in a way that was never possible before, providing new insights into the fundamental processes that shape the universe. And while the pillars of creation remain a stunning example of Webb's capabilities, they're just the beginning. Another exciting discovery Webb has made is the detailed study of a so-called reflection nebula in the Snake Nebula, located around 1,300 light-years away. Unlike emission nebulae, which glow with the light from young, hot stars, reflection nebulae don't emit their own light. Instead, they're illuminated by nearby stars, which shine light onto the dust and gas in the nebula, causing it to reflect that light and glow faintly. Webb's observations of this nebula have revealed new levels of detail, uncovering gas and dust structures that were previously hidden from view. The intricate patterns of gas and dust in the nebula, along with the intense light from the young stars within it, give us a glimpse into the processes that shape these regions of space. And in Webb's infrared images, we can see this glow in a way that was never possible with earlier telescopes. But what's especially fascinating about these reflections is the presence of young stars still in the process of formation. Many of the stars in the Snake Nebula are less than 100,000 years old, meaning they're still in the early stages of their life cycle. While they're already quite large and hot by cosmic standards, they still have a long way to go before they reach full maturity. This is yet another example of how Webb is allowing scientists to study stars in all stages of their development. From the pillars of creation to the Snake Nebula, Webb is shedding light on the birth of stars and the role that gas and dust clouds play in their formation. One of the most intriguing aspects of Webb's discoveries is the way it's revealing new, mysterious objects that don't fit neatly into our current models of the universe. For example, Webb has uncovered galaxies that shouldn't exist based on our current understanding of cosmology. According to scientists, some of these galaxies are too old, too massive, or too far away to have formed the way they did. These findings have sent ripples through the scientific community, forcing astronomers to reconsider their models of galaxy formation and evolution. Webb's deep field observations have revealed galaxies that appear to be much older than they should be, with some even dating back to within just a few 100 million years after the Big Bang. These galaxies are challenging our theories of how galaxies form and evolve, suggesting that the processes that govern the early universe may be more complex than we ever imagined. Webb's ability to observe distant galaxies in such detail is a major breakthrough. In the past, astronomers had to rely on indirect methods to study the early universe, such as analyzing the light from quasars or using computer simulations to model galaxy formation. But with Webb, we can directly observe galaxies that formed when the universe was still in its infancy. These observations are allowing scientists to study galaxies at different stages of their evolution, helping to piece together the history of the universe in a way that was never before possible. Beyond galaxies, Webb is also exploring the atmospheres of exoplanets, planets that orbit stars other than our Sun. In the search for life beyond Earth, exoplanets are a key area of focus. Webb's instruments have allowed scientists to study the atmospheres of exoplanets in unprecedented detail, looking for chemical signatures that could indicate the presence of life. One of the most promising candidates for this search is a planet called K2-18b, which orbits a red dwarf star about 120 light-years away. This planet has been a subject of fascination for years because of its potential to support life. Recent data from Webb has revealed the presence of several key molecules in its atmosphere, including methane, carbon dioxide, and dimethyl sulfide, DMS, a compound associated with marine life on Earth. While these findings are still being studied and debated, they represent an exciting step forward in the search for extraterrestrial life. The detection of DMS, in particular, is significant because it's a molecule that's produced on Earth by marine organisms. While its presence on K2-18b doesn't guarantee the existence of life, it raises intriguing possibilities and opens up new avenues for research. Webb is also helping to refine our understanding of the broader exoplanet population. For example, it has captured some of the first direct images of exoplanets, offering a glimpse of these distant worlds in a way that was previously impossible. One such exoplanet, a superjupiter in the Epsilon Indi system, is particularly fascinating. This planet is about 3 times the size of Jupiter and orbits a triple star system located just 12 light-years away. Webb's observations of this superjupiter have revealed new information about its atmosphere and orbit, including the fact that its orbit is highly elliptical, meaning that the planet spends part of its time much farther from its star than it does at other points in its orbit. This unusual orbit could help scientists understand how gas giants like Jupiter form and evolve, and may even provide insights into the processes that govern the formation of planetary systems. Webb's ability to directly image exoplanets is one of its most exciting capabilities. Most of the exoplanets discovered so far have been found using indirect methods, such as the transit method or the radial velocity method, which detect the presence of planets by observing the effects they have on their parent stars. However, these methods don't provide direct images of the planets themselves. With Webb, scientists can capture direct images of exoplanets, giving them a much clearer picture of these distant worlds. These images, along with the data gathered from Webb's spectrometers, are providing new insights into the atmospheres and compositions of exoplanets, helping to refine our models of planet formation and evolution. As Webb continues its mission, it's clear that we are only scratching the surface of its potential. With its ability to observe the universe in unprecedented detail, Webb is opening up new frontiers of discovery that will keep scientists busy for decades to come. From unraveling the mysteries of star formation to studying the atmospheres of distant exoplanets, Webb is providing a treasure trove of data that will shape our understanding of the cosmos for years to come. And as Webb continues to reveal more of the universe's secrets, we can only imagine what astonishing discoveries are still waiting to be made.